Chapter P, Section 2, Exponents and Scientific Notation. Can 3 times 3 times 3 times 3 be expressed another way? Sure. How? Well, how many times do the 3's appear? 4 times. So we can write this as 1 base of 3 raised to the power of 4, indicating that we are going to multiply 3 by itself 4 times. The integer 3 is known as the base, and the power that it is raised to, in this case 4, is known as the exponent. This is just a review of basic algebra 1 vocabulary. Sometimes it's a little bit tricky, depending on the way it's written, for students to figure out what the base and the exponent is. So be careful on that. What is the base in this example? 5 raised to the power of 7. Well, the base is 5, and the exponent is 7. 7 raised to the power of -2. Now, maybe you didn't pick up that negative there, but it is raised to the -2 power. The base is 7, and the exponent is -2. -2 raised to the power of 3. What is the base? I'll give you a moment to think. What is the base? What do you think the base is? The base here actually is 2. The negative is not part of the base. If you look at example 4, these are a little bit different. This one means take 2 cube it and then make it negative. This one here says take the negative and raise that also to the power of 2. So you have to be careful when there are no parentheses versus when there are parentheses. The negative inside the parenthesis indicates that that negative is also being raised to that power. So be careful of that. So again, -2 cubed, what's the base? 2. What's the exponent? 3. And here, parenthesis -4 squared. What is the base? The base is -4. And what is the exponent? The exponent is 2. And sometimes students get, excuse me, that mixed up, and we'll talk a little bit more about things when you're raising it to the 0 power and that. Okay. Back on, the multiplications that are expressed in exponential notation are read as follows. This is 10, the exponent, base is 10, exponent is 1. So we typically would say this as 10 to the first power. Now remember, the exponent 1 typically is not written. And so, you know, if they were asking you, if it was just the number 10 and you were asked to give the base and the exponent, you would automatically know that 1 is the exponent, or that that would be 10 to the first power. This one here is 10 to the second power. I'm using ditto marks to indicate that those words are the same, so I don't have to keep writing it. You could also say this as 10 squared. This one, 10 raised to the power of 3. That's 10 to the third power, or 10 cubed. 10 to the power of 4 would be 10 to the fourth power. And then here we have 10. The exponent this time is n. This would be read as 10 to the nth power. Pretty simple, pretty straightforward. All right, what's next? Evaluate. Look at the base word in evaluate. It's value. We're trying to find the value here now. Evaluate the exponential expressions. Now you have to be cognizant of the fact whether or not a negative is included in raising to that power or not. It's also going to benefit you if you know your squares and your cubes, especially, you know, like 1 through, well, you should know 1 through 12 quite fluently for your squares. And in fact, it would probably behoove you to know 1 through 20 squared. And then number 25. 25 squared, of course, is 625. Those more often than not, show up a lot in our textbook. And the cubes, you probably really should be familiar with 1, 2, 3, 4, and 5 cubed. So 4 cubed is 64. I am cubing the negative, and so when I raise negative 4 to the power of 3, that's going to give me a negative 64. And then, of course, here, multiply with, 2 squared that's 4. And when I multiply 64 with 4 and then make it negative, because I have a negative being multiplied with a positive, my answer here is negative 256. So the value of that expression is negative 256. This example here, and I guess let me try to zoom in a little bit closer. I've got a negative and then a 3 squared. Now, if this was in parentheses, this would be positive 9, but it's not in parentheses. The negative has to stay on the outside. The negative is not being raised to the second power. 3 squared, of course, is 9. And then 2 to the power of 4, 2 cubed is 8 times 2 is 16. This is 9 times 16. And 9 times 16 is 144. Negative times a positive is a negative. So my value of this expression is negative 144. I'm going to zoom out a little bit. Some of the font on some of these note sheets are a little bit small. We're going to break this section down into 3 videos. This is just part 1 of the 3 videos. If you have any questions on anything, please leave a comment on the homework discussion. Okay, side 2. Discovering patterns with exponents. I'll write this in a different color. Let's do pink. 2 to the power of 4. Well, I already know 2 cubed is 8. If I multiply 8 by another 2, I got 16. 2 cubed is 8. 2 squared is 4. 2 to the power of 1 is 2. 2 to the power of 0. If I look at the pattern, what's happening here is I'm cutting in half every step of the way. Half of 16 is 8, and half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is a half. Half of a half is a quarter. Half of a quarter is an eighth. And 1/2 of an eighth is a 16th. And really the pattern, what you should be seeing here is when you have negative exponents, if you take the reciprocal, move this base with a negative exponent down to the denominator, the exponent becomes positive. So this is really 1 over 2 to the positive 1 power. And this one here, 2 to the negative 2, is really 1 over 2 squared, and that equals 1/4. And this one here is really 1 over 2 now to the positive 3, and 2 cubed is 8, and here I get 1/8. And then the last one here is really 1 over 2 to the positive 4. And 2 to the 4th is 16, so this becomes 1 over 16. So how do you get rid of negative exponents? You move it to the denominator if it's in the numerator. And vice versa, if it's in the denominator as a negative exponent, just move it up and it changes the sign of the exponent. We'll do another little pattern here with exponents. 3 to the power of 4. Well, 3 squared is 9. The other 3 squared would be 9. Now I'm breaking down the 4, this thing right here. I'm breaking it down as 3 times 3 times 3 times 3. 3 squared is 9. The other 3 squared is 9. And 9 times 9 is 81. That's how I think of numbers. 3 cubed is 27, and maybe you just know the cubes because you're good with numbers. 3 squared is 9. 3 to the power of 1 is 3. Here, let's look. 81 divided by 3 is 27, divided by 3 is 9, divided by 3 is 3, divided by 3 is 1. And so here we see that any non-zero base raised to the power of 0 is always going to be equal to 1. This here, we're going to think of this as the same way that we did here with the squares, the negative exponents. Not the squares, the base 2 with the negative exponents. So 3 to the power of negative 1 is going to become 1 over 3 to the first, or 1/3. This becomes 1 over 3 squared, or 1/9. This becomes 1 over 3 cubed, or 1/27. And this one here becomes 1 over 3 to the power of positive 4, which is 1 over 81. Okay, so make sure you don't forget about that rule that to make the exponent positive, you move it from denominator to numerator or numerator to denominator, and that changes the sign of the exponent only. Only changes the sign of the exponent, never the sign of the base. Because notice, all of these numbers were positive, and all of these numbers are still positive. You're never going to change the sign of the base, only the sign of the exponent. Conclusion. Any real number other than 0 raised to the 0 power is always going to be equal to 1. Any real number other than 0 raised to a negative power, what you're going to do is take the reciprocal of that number and raise it to the positive power. Okay, so example, we had 2 to the negative 2. Well, that becomes 1 over 2 squared, which is 1/4. Well, suppose maybe we had 1 over 2 to the negative 2 power. I'm going to move this up to the top, and that's going to become 2 squared over 1. I'm not going to move this one because this one already has a positive exponent. This in the denominator is really 1 times this, so that's why that 1 is there. And 2 squared is 4. 4 divided by 1 is 4. So again, wherever it's negative, if it's negative in the numerator, move it to the denominator. If it's negative in the denominator, move it up to the numerator. Okay, a little bit more. Evaluate the following. 5 raised to the power of 0 is 1. Negative 3 raised to the 0 power is 1. This negative is included in raising to that power of 0. Negative 4 to the 0 power is negative 1. This part right here equals 1. This part right here stays. Okay, so just make sure that you know the difference between these two, whether or not the negative is including in raising to that power. 2 raised to the negative 3 power. Well, we know the negative 3, this is going to go in the denominator. So I'm going to have a 1 over 2 cubed, or 1/8. This base is negative in the denominator. I'm going to move it up. I have to keep a 1 in the bottom. 1 multiplied with this is this. And so the 1 is always there. So this becomes 6 raised to the positive 2 power, which is 36. And of course, in a similar fashion, I'm going to move this 3 to the power negative 4 up. This is going to become 3 to the positive 4 power over 1, which equals 81. And the more of these that you do, you get used to it. When you move it up, down, it changes the sign of the exponent only. Now, in your book, the book does go through a whole bunch of these rules, and they're little baby problems, and they're all kind of easy. And then all of a sudden they give you a monster problem, and you have to know all of the properties at one time. So it can get kind of confusing. For the purposes of the notes, not so confusing, but when you get a big ginormous problem, then you're like, wait, what just happened? So let's really learn the baby problems really well. When you're multiplying exponential expressions with the same base, what do we do with the exponents? 3 cubed times 3 squared. Now, I always draw out or give the longhand form of what this means for the first problem, and then each successive problem, I don't do that same thing. So, in other words, what do I mean? Well, what's 3 cubed? 3 cubed is 3 times 3 times 3. Multiply the base by itself as many times as what the exponent says. 3 cubed is 3 times 3 times 3. Here's my dot, that's that dot, and 3 squared, of course, is 3 times 3. This is the illustration of what's going on here. This is the short version, this is the long version. Well, let's count them up. 3, 3, 3, 3, 3. How many are there? Oh, 5. So this is 3 to the power of 5. Now you wouldn't leave it like this because this is a numeric base raised to a numeric power. And so put this on your calculator and tell me what 3 to the power of 5 is. But let's first look at what the rule is. Well, the rule is, what do you do with the exponents? I've got 3 here and 2 here. I ended up with 5. What do we do with them? You are correct. We add them. So I could have simply said, oh, the bases are the same, so I add the exponent. This would be 3 to the 3 plus 2 power, or 3 to the 5th. And then again, like I said before, you must simplify this. 3 raised to the power of 5 is 243. 2 squared being multiplied with 2 to the negative 5 power. We know bases are the same, operations multiplication, we add the exponents. This will become 2 squared. This, I'm sorry, this is 2 to the negative 5, so I'm going to add the exponents. So again, it's 2 plus negative 5, which really is 2 to the power negative 3, which becomes 1 over 2 cubed, which is 1/8. Now, I'm okay on a test or a quiz for the purposes of showing work. I'm okay if you go from here to here to here. Okay, but this is our notes. And the more you have in your notes, the better it's going to be, say, if you look back on it, I don't know, 2 months from now, or even a year if you plan on taking this notebook to college with you. So that's my recommendation, just to copy all the notes down, even though it might seem painful. You know, I sometimes think of this problem another way. You know, I could think of this problem as 2 squared over 2 to the positive 5 power. And then I say to myself, well, you know what? 2 of these will kick out 2 of these, leaving me with 3 left. And so when there's nothing here, it's not a 0, because this is really 1 times it. So this becomes 1 over 2 cubed, or 1/8. That's like my shortcut way of thinking about doing these problems. But in the book, they wanted you to know about this product rule. If the bases are the same, you simply just add the exponents. I think I'm going to stop there, and there will be another video for you the next day, tomorrow, that continues this. Let's see, where else are we going with this? We are going to talk about the power rule, the quotient rule, products to powers, quotients to powers. Then we're going to give a summary of exponents and talk about what an exponential expression in simplified form looks like. All these things must be true. And then we're going to do some problems that involve a whole bunch of this stuff together. And then we're going to take a look at scientific notation, how to multiply with it, how to convert from scientific notation to decimal form. Here's where we're going to be multiplying with them and then dividing with those expressions, and then we'll have an application problem. So until the next lesson, which is going to be part 2, and then the following day, part 3, and you'll get a book assignment. Have a great day.